Welcome to clickmyproject.com. We are going to see the product for dual use of power lines for Design-for-Testability, a CMOS receiver design. Next we are going to see the abstract for our product. As the circuit complexity increases, the number of internal nodes increases proportionally, and individual internal nodes are less accessible due to the limited number of available input-output pins. To address the problem, this product has power line communications at the IC level, specifically the dual use of power pins and power distribution networks for application observation of test data as well as delivery of power. A PLC receiver presented in this product intends to demonstrate the proof of concept, specifically the transmission of data through power lines. The main design objective of the proposed PLC receiver is the robust operation under variations and droops of the supply voltage rather than higher data speed. Each new generation of deep submicrometer VLSI technologies, testing, debugging and diagnosis of VLSI circuits become more difficult and expensive. In addition to higher circuit complexity for a deeper micrometer technology, larger process variations, greater interconnection delays relative to transistor switching time, and larger leakage current also contribute to make the testing more challenging. It is a general consensus among test. Our product gives the solution for all the problems. Next we are going to see the flow diagram for our product. The flow diagram consists of level shifter, signal extractor, logic restorer. The proposed on-chip PLC receiver receives the data superimposed on power lines, and the data such as scan test data are sent from a test instrument. Therefore, the transmitter for the PLC receiver is external instrument rather than the one on the same chip. The receiver was designed in CMOS technology. It consists of three building blocks. The PLC receiver consists of three blocks, each sharing the same supply voltage. The first block is a level shifter, which lowers the DC level of the signal superimposed on the supply voltage. The level shifted signal is processed by the subsequent block, a signal extractor, which amplifies the signal into a differential signal. The logic restorer, which is a differential schematic trigger, recovers logic values from the differential signal. The design and operation of each block is explained. When the common source amplifier with the diode connected, the level shifter propagates the data signal imposed on the supply voltage VDD to the output, while lowering the DC voltage level of the signal. The propagated data signal superimposed on the supply voltage to the output. The output should be sensitive to supply voltage variations. The typical amplifier design, the power supply rejection ratio of the level shifter should be set to small. The input signal or signal extractor is a data signal. Next we are going to see output for our product. We create the design in the Tanner version 13.0. To create a new project, we have to click on the file and then click on the new and then new design. For the cell creation, you have to click on the cell and then click on the new view. We can change the cell name. Once we design our design, then we have to click on the setup and then give the space simulation. Here we have to copy the library files in our folder. Then the transient Fourier analysis contains the timing. Then we have to click on the run button to simulate our project. We can add the library files by clicking on the add. The designs consist of the CMOS. Then we can add the library files that is given in our folder. Next we are going to see the output waveform. For this we have to click on the start simulation. This is the output waveform. We have to click on the expand shot. the graph will be generated. Then you have to click on the FFT to see the frequency. Then again click on the expand chart. Here we can get the frequency separately. Then close the waveform. Thank you.